So, picture this. Imagine a future where artificial intelligence doesn't just chat with you to brainstorm ideas or summarize articles, but actually takes action. A future where you can hand off a really complex, multi-step problem, and the AI autonomously figures out the workflow, writes the code, corrects its own errors, and executes the entire task perfectly from start to finish. Welcome to This Explainer. Today, we're zooming in on a massive, truly monumental evolutionary leap in the tech industry. We're moving away from standalone large language models that basically act as isolated brains, and we're stepping right into the era of multi-agent compound systems. And the engine driving a huge part of this shift? It's an absolutely incredible open source framework called AutoGen. Okay, let's look at our roadmap for this explainer. First, we'll go beyond generative AI. Then, we'll explore the multi-agent advantage. Third, introducing AutoGen. Fourth, powerful agentic design patterns. And finally, real-world AI orchestration. Let's dive right in. Section 1. Beyond generative AI. We really need to ground ourselves here in this huge paradigm shift. For the last few years, right, we've all been totally captivated by generative AI. And look, generative AI is fantastic at spitting out content, whether that's drafting an email, writing a poem, or generating an image. But agentic AI? It's fundamentally different. Agentic AI actually takes agency. It's designed to execute complex, multi-step tasks on your behalf with very minimal intervention. It doesn't just generate text, it actively solves problems. To really ground this, instead of your standard chatbot, imagine having an autonomous tech advisor that can proactively troubleshoot your faulty printer step by step, running diagnostics entirely on its own. Or maybe a dedicated science agent that can process vast amounts of research data, or a software agent that writes, tests, and deploys code autonomously. It's a real game changer. Section 2. The multi-agent advantage. Which naturally brings up a pretty obvious question, right? If we want AI to do all these complex things, why not just build one massive, incredibly smart AI model to do it all? Well, the data brilliantly illustrates why that single model approach is actually kind of flawed. When you force one single instance of GPT-4 to handle a super complex task alone, it does okay. But when you set up a multi-agent framework utilizing GPT-4, the performance just skyrockets. We're talking a 96% F1 score, which is a massive leap in overall accuracy, and a stunning 98% recall, meaning it almost never misses the right answer. The multi-agent setup vastly outperforms a lone model trying to juggle the whole shebang. The secret behind this massive jump in quality? It's a concept literally as old as time: divide and conquer. By breaking a complex workflow down into smaller pieces and assigning them to specialized AI agents, you allow for natural iteration. One agent generates an idea, another critiques it, and a third executes it. It perfectly mimics human teamwork, leading to infinitely better problem solving. Section 3. Introducing AutoGen. So how do we actually build these incredible collaborative teams of AI? Enter AutoGen. It's this intuitive programming paradigm that basically serves as the glue for compound AI systems. It's specifically designed to weave together diverse language models, external code execution tools, and, this is absolutely crucial, human feedback. It's the orchestration layer that lets all these disparate parts communicate natively. You can think of this architecture exactly like a human company's org chart. You might have a commander agent acting as the project manager, seamlessly delegating a specific coding task to a writer agent. And once the writer finishes, the code doesn't just get deployed blindly. It's passed right over to a safeguard agent whose sole job is to review that code for security and safety. Let's look at how this plays out dynamically in a real-world scenario. Say a user asks a really tricky supply chain question like, what if we prohibit shipping from supplier 1 to roastery 2? The commander takes this prompt and routes it directly to the writer to generate the optimization code. But before handing the user an answer, the commander passes that code to the safeguard. If the safeguard flags an issue, the system just loops back automatically. It iterates until a final, safe, and verified answer is generated for you. Section 4. Powerful agentic design patterns. Okay, so we know the basic structure, but how do we actually architect these complex behaviors in code? What makes AutoGen an absolute powerhouse is its insane flexibility. Developers aren't locked into just one way of doing things. You can wire agents together in a simple sequential chat, passing a task right down an assembly line.
Or you can create nested chats, dynamic group chats where anyone can jump in and speak, or sprawling hierarchical structures where AI managers oversee entire teams of subagents. It literally scales to match the exact complexity of your task.
To put this in perspective, imagine a basic two-agent reflection setup. A blog writer drafts a post, and a critic gives feedback. Pretty straightforward, right? But then, contrast that with a highly complex nested chat. In this advanced setup, the critic agent doesn't just reply, it simultaneously triggers dedicated SEO, legal, and ethics reviewer agents, aggregates all of their feedback, and then hands a comprehensive critique back to the writer. And then there's the conversational chess example, which takes things a step further, proving these agents don't just talk to each other in abstract language. They actively compete and interact with the real world. In this setup, as the AI and a human play chess, the agents are actually utilizing external tool registries, triggering Python scripts to validate if a move is legal on the actual board in real time. No way, right? Now, even in a massive group chat, AutoGen keeps things from turning into total chaos using state flow logic. This means you can build state-driven workflows that move chronologically. The system predictably transitions from initialization to retrieving code to conducting research and finally to completion. This ensures the AI doesn't just get lost in an endless loop of conversation. Section 5. Real-world AI orchestration. This level of control is exactly why this tech is breaking out of the lab. Let's discuss its real-world impact. It is definitely worth looking at the broader landscape here. You've probably heard of other frameworks out there, like LangChain's LangGraph or Crew AI. Now, while those offer really great high-level static workflows or graph-based control, AutoGen really stands apart for its comprehensive, dynamic conversational programming. It allows agents to fluidly converse and solve problems in ways that rigid graphs sometimes just restrict. And let me tell you, the industry is responding to that flexibility in a massive way. AutoGen's traction is absolutely explosive. We're currently seeing a staggering 200,000 downloads of this framework every single month. That's huge. On top of those downloads, it's racked up over 30,000 stars on GitHub, which is a massive stamp of developer approval. It's built this super passionate Discord community of over 20,000 active developers, firmly solidifying AutoGen's position as a top 100 open source achievement globally. So, why does all of this actually matter for you? Well, it matters because AutoGen allows for the rapid exploration of these multi-agent setups. It lets developers conduct really complex AI experiments at an enterprise scale. Ultimately, without this specific ability to rapidly orchestrate and scale multi-agent configurations, the true potential of compound AI systems would remain permanently locked away. We're literally transitioning from just interacting with singular, isolated models to managing intelligent digital workforces. So I'll leave you with this to ponder. If frameworks like AutoGen are making this orchestration seamless today, what happens tomorrow when every single piece of software you use stops being a static tool and instead becomes a vibrant team of intelligent, autonomous agents working completely on your behalf? Thanks for joining me on this explainer, and keep exploring.